Imagine you're handed four identical-looking clear liquids. One could be a harmless alcohol, another a pungent carboxylic acid, a third a sweet-smelling ester, and the last, perhaps, a reactive aldehyde. To the naked eye, they are indistinguishable. But in the world of organic chemistry, these molecules hide their identities in their functional groups, the specific clusters of atoms that dictate how a substance behaves. How do we unmask them? In the lab, we don't need expensive machinery. We just need to ask the right chemical questions. Let's start with the most common group, the alcohols. Suppose we drop a tiny piece of metallic sodium into our mystery liquid. Notice how bubbles immediately begin to fizz and rise to the surface. That's hydrogen gas being displaced. If we want to be even more specific, we can use the esterification test. By adding a bit of acetic acid and a drop of sulfuric acid, a fruity, pleasant aroma begins to waft from the test tube. If you smell that artificial strawberry or apple scent, you've likely found an alcohol. But what if the liquid remains stubbornly still when we add sodium? Let's shift our focus to the carbonyl groups, aldehydes and ketones. To tell them apart, we use what I like to call the silver mirror test, formerly known as Tollens reagent. Watch what happens when we add this clear reagent to an aldehyde and gently warm it. A thin, shimmering layer of metallic silver begins to coat the inside of the glass. It's one of the most beautiful sights in the lab. If the solution stays clear, it's probably a ketone. Why? Because aldehydes are eager to be oxidized, while ketones are much more chemically guarded. Now, look at this third beaker. If we suspect a carboxylic acid, we use a test so simple you might have done it in your kitchen. We add a pinch of sodium bicarbonate, baking soda. As you can see, it immediately erupts into a brisk effervescence. That's carbon dioxide gas escaping. This is the hallmark of an organic acid. It's strong enough to kick the CO2 out of the bicarbonate, something a simple alcohol could never do. Finally, we have the amines, the nitrogen-containing compounds. These often announce themselves with a fishy, unpleasant odor. To confirm their identity, we perform the carbalimine test. When heated with chloroform and potassium hydroxide, a primary amine will produce a smell so foul and pungent it's unmistakable. It's nature's way of saying, yes, there's nitrogen here. The beauty of these tests isn't just in the color changes or the smells, it's in the logic. We aren't just memorizing recipes, we are probing the electronic heart of the molecule. By observing whether a bond breaks or a gas escapes, we are effectively shaking hands with the atoms to see how they respond. Next time you see a clear liquid in a chemistry lab, remember, its identity isn't hidden. It's just waiting for you to ask the right question. Chemistry isn't just about what things are, it's about what they do when they meet a friend.